You know, when we picture a trip to the moon, we usually just imagine a rocket flying in a simple, straight line, right? But the reality of Apollo 11 was an absolutely breathtaking mechanical puzzle.
Because landing on the moon was not simply a matter of flying downward. Apollo 11 had to divide one spacecraft into two, land one part on another world, and reunite both parts before returning to Earth. Let's look at exactly how they pulled off this impossible choreography.
Part 1. The Kennedy Challenge, Crewed Landing and Return. This entire mission architecture was actually born out of a very specific objective set by President Kennedy back in 1961 to safely land a man on the moon and get him back before the decade closed. By 1969, an army of engineers had transformed that bold political mandate into a massive, tangible machine.
And the sheer scale of the math here is just staggering. We're talking about a 950,000-mile round trip. That meant building a machine that could survive violent launches, coast through the freezing void of space, split apart, and then precisely find itself again in a total vacuum. Part 2. Journey to the Moon. July 16, 1969, Saturn V launch.
Lifting off on July 16, 1969, the towering Saturn V rocket pushed the crew toward history. To really wrap our heads around this mission, look at this precise 9-day roadmap. Launch on day 1, a lunar landing on day 5, and a triumphant return to Earth on day 9. Literally every single second was meticulously calculated.
So about 2 hours and 44 minutes after launch, during what's called the trans-lunar coast, a seriously complex maneuver takes place. The command module, named Columbia, separates from the rocket's adapter, physically turns itself completely around in space, and docks head-to-head with the lunar module, the Eagle. It basically plucks it out for the journey ahead.
Part 3. A spacecraft divided, Columbia and Eagle docking. By July 19th, the joint spacecraft slipped into lunar orbit, and this is where the mission fundamentally required two distinct roles. See, Columbia was a heavily armored command center, built specifically to survive Earth's scorching re-entry. But the Eagle? It was incredibly fragile, designed purely for the vacuum of the moon, where aerodynamics just completely ceased to matter.
So, the crucial point here is that not everyone went down to the surface. On July 20th, Armstrong and Aldrin entered the Eagle and undocked. But Michael Collins stayed behind. He remained completely alone in Columbia, orbiting the moon, managing vital communications, and photographing the surface from above.
Part 4. Descent to Tranquility, Manual Control, and Avoiding West Crater.
Going down was one of the most perilous engineering challenges ever faced. As Eagle descended, the tension was unimaginable. The onboard computer was actually steering them directly toward a sharp-rimmed crater surrounded by massive, ship-destroying boulders. And to make matters worse, they only had seconds of descent fuel remaining. Faced with this potential disaster, Neil Armstrong seized manual override. Acting with absolute precision, he hovered the module, manually translating its position horizontally across the lunar landscape. He was desperately looking for a safe, clear, flat landing spot before those tanks ran totally dry. At exactly 102 hours and 45 minutes into the mission, the descent engine kicked up a huge cloud of lunar dust. The footpads made contact, and history was made. On July 20, 1969, Armstrong sent those iconic words back to Earth, "The Eagle has landed."
Part 5. The Journey Home, Ascent from the Lunar Surface. But here's the thing. Getting down was only half the job. Now came what was arguably the most terrifying phase, a reunion in space. This perfectly illustrates the genius of Eagle's design. It was actually two completely separate parts. The bottom descent stage was intentionally left behind forever, basically serving as a launch pad for the top half to blast off.
So on July 21st, this precise sequence plays out. The ascent engine fires, lifting Armstrong and Aldrin back into the blackness of lunar orbit. From there, they execute a highly complex orbital rendezvous, perfectly aligning and docking with Michael Collins, who was waiting for them in Columbia.
Once they were safely reunited inside Columbia, the invaluable lunar rock samples were transferred over. The now useless Eagle ascent stage was jettisoned into space, and Columbia fired its main engine, blasting the crew out of lunar gravity for a high-speed plunge toward Earth.
As they approached Earth, the spacecraft shed its final bit of unnecessary weight. The service module was discarded, leaving only the cone-shaped command module.
Shielded by a specialized heat shield, it was the absolute only piece of that massive Saturn V rocket to actually streak through the searing heat of Earth's atmosphere. After braving the fires of re-entry, the capsule's parachutes deployed beautifully. On July 24, 1969, the crew made a safe splashdown in the Pacific Ocean, coming to rest just 13 miles away from their recovery ship, the USS Hornet.
The sheer scale of this accomplishment is still staggering today. Apollo 11 succeeded because thousands of people transformed an almost impossible journey into a carefully connected system of machines, calculations, and human decisions. It really leaves you wondering, when we apply that same level of unified human ingenuity today, what other impossible journeys might we finally conquer?